Hey everyone, Chang here and welcome to my channel. Today I'm going to talk about a topic that seems extremely scary when we first encounter it, but actually it's not all that bad. It looks something like this. Here is basically simplification of polynomial. We have a cubic function on top and we have a monomial at the bottom. Now, normally in this situation, you will encounter these kind of problems. Either they're asking you to graph or in this case, simplify. Now, simplifying is a really great tool because looking at this is almost impossible to sort of visualize this right away. But if you simplify it, then you get an easier sort of view of what the graph would end up looking like. Of course, the bottom still has the whole, domain and range idea that you guys can look at. I do have a video on it, so I'm going to leave a link in the description. But mainly we're focusing on simplifying polynomials right now. Now, first and foremost, before we even go through long division, the first thing you got to check is the largest exponents, right? In this case, here it's cubic, and the bottom one here is a monomial, right? Is this bigger than that? If it's not bigger than that, then there's really nothing you can do, right? There's no real simplification. But if it's bigger, then you can actually carry out the long division. Now, long division is actually really scary with variables, but I'm going to show you. If you look at this, which is a standard division problem, or something like this, which is actually just slightly different, if you can solve these two, you can solve this no problem. Now, let's look at this for example. How many times can 4 go into 1,724? Basically, you're getting 1,724, you're dividing it by 4. So, this one, you go here. Well, the first number, 4 can't go into 1, so we go to the next one. That's 17, right? We're looking at these two digits. 4 goes into 17 4 times, right? Because that's 16. And then we basically pay attention to this. What you do is you subtract. Now you have 1, and you carry the next digit down. Now you have 12. 4 goes into 12 how many times? Well, that's going to be 3, right? That's 12. And then once again, you subtract. Then you carry out the next digit, which is 4. Goes into 4 how many times? 1. There you go. Simple as that. Right? Let's look at the next one. I changed it specifically. If you catch it immediately, you realize that the difference between this and this is just 1. So it's going to be this, but with a remainder of, well, you guessed it. Right? So here we are. 4 goes into 17 how many times? Well, we have 4 right here, and that's still going to be minus 16. We have 1, 2 right here. It's going to be 3, and it's going to be minus 12. And this time, instead of bringing down the 4 from this original problem, this is going to be bringing down the 5. 4 still goes into 5 one time, right? So you subtract 4, but now you have 1, and you have no more digits to bring down. Normally, there's two ways we go about it. We either say, okay, now we have a remainder 1, which is good. Right? That just means that we have 431 and remainder 1, if we want to write it like actually, I guess you could say in a fraction form to completely finish the solution, it's going to be 1 over, which is the remainder, whatever you're dividing by 4. So it's going to be 431 and 1/4. Right? Of course, there's the other way where instead of remainder 1, we put a little decimal and we put 0 all the way forever until we eventually either repeat or we end up with some decimal form. In this case, if we look at it, it's probably going to be 431.25. But this part about using the decimals, we don't really care about. It's the idea that we can actually just divide, or we can divide with remainder that really helps us with long division. So let's look at this really quickly. I'm going to do exactly this, except for now we have variables, which is scary, but not bad. Let's rewrite this. 3x cubed minus 2x squared minus 13x plus 10. Okay, now we're dividing, so once again, at the bottom, right? So you're going to draw this whole thing right here, and we're going to have x minus 2. All right, cool. Now, the thing is, we're going to pay attention usually to the front part. And we're going to do exactly what we're doing here. So we're going to figure out how many times, for example, this goes into here. How many times does x go into 3x cubed? Well, this is pretty simple. That's just 3x squared. Okay? Well, if that's the case, 3x squared times x is 3x cubed. 3x squared times negative 2 is just minus 6x squared. Oh, sorry, I need to write here and make sure to copy the problem correctly. That's one thing. All right, so here we have it. Okay, cool. Now, remember, after we figured out the multiplication aspect of it, right, 4 times 4 is 16, we subtract. So that's the same thing. Think of it like this. we're going to subtract this whole thing from up here. So what do we have? Well, 3x cubed minus 3x cubed. That's good. That's what we want, right? We get rid of it. Now here we have negative 2x squared minus a minus. So this actually becomes plus. So this is going to be a plus 6x squared. So that's going to give us 4x squared. Then instead of bringing just a single digit, we're going to bring the next term down. That's minus 13x. Okay? Now we ask ourselves again, this times what gives us this? Well, this is x. We need to multiply by 4 times x to give us 4x squared. So let's just do this right here. It's going to be plus 4x. Okay? Well, if that's the case, this times this gives us what we want, 4x squared. Now, 4x times a negative 2 is going to be negative 8x. Cool. Once again, we are subtracting this whole thing. This goes away, of course. And then this one right here is going to be negative 13x minus a minus, which is going to be plus 8x. So that's going to be negative 5x plus 10, because I bring the next term down. Well, in that case, how many times does, or what must x multiply to get negative 5x? Well, that's simple, negative 5. So that's going to be negative 5x, and it's going to be negative 5 times negative 2, which is going to be positive 10. And now this looks exactly the same, which is a good thing, because remember, what we're going to do is we're going to subtract. So that means everything cancels out, right? It's 0. So if that's the case, this is it. This whole thing right here, divided by x minus 2, is just this final answer right here. 3x squared plus 4x minus 5. Okay. Now, this next one is slightly different, right? We can write this x cubed plus 8, and then we do the division sign, and then we do x plus 2. But I would warn against that just for these kind of problems. The reason for that is because there's a lot of sort of, I guess you could say, missing terms, right? That would mess up your organization like crazy. So instead of writing it like this is what I would hope you guys would be able to write. So we have x cubed. That's cool. But then we're going to go down a step and think about x squared. How many x squared are there? Nothing. But instead of just leaving it blank, we're just going to put plus 0 x squared. Same thing with the next one, x, right? How many x are there? Nothing. Instead of leaving it blank, plus 0x, then plus 8. This is more of an organization thing. So that when you start dividing, you got to remember there's still these terms you have to consider. So let's look at this. We have x plus 2, which is what we're dividing x cubed plus 8 by. And if we wrote it all out with these two terms technically 0, because they're just nowhere to be found, right? And then afterwards, we start dividing it. So here we have x cubed. X, this is the one we're paying attention to. X times something give us x cubed. Well, that's pretty simple. That's just x squared. Okay, well, if that's the case, then x squared times x is x cubed, what we want. And then x squared times 2x, that's plus 2x squared. That's why we need that, to help us basically keep this organized, to keep it in line. Well, if that's the case, once again, don't forget, whatever we do, we got to subtract it. Right? So this goes away, that's what we want. And then now, 0x squared minus 2x squared. So what we have is a negative 2x squared. Then we bring the next term down. That's plus 0x. Okay, cool. Now, this right here times something gives us negative 2x squared. Well, that's an x, so what we have to multiply by is negative 2x. That gives us our negative 2x squared. Well, negative 2x times 2 is just negative 4x. Once again, we're going to subtract this whole thing. Well, this cancels, is what we want. And then this one, a minus. Remember, we have 0x, doesn't really matter. Minus a minus is now plus. So technically we have a positive 4x. Then we bring the next term down, plus 8. And once again, x times something gives us 4x. In this case, 4. So we're just going to do a positive 4 plus 4. And then there we have 4x. And then 2 times 4 is just 8. Cool. And then once again, we subtract. Luckily for us, this goes away, so that's 0. That means there's no remainder. That means our final answer from this divided by x plus 2 is just x squared minus 2x plus 4. Remember, this is not that complicated. The only, I guess you could say, hiccup that you could potentially encounter is if you forget that in between the cube and basically the constant, there's always the term x squared and then x. And of course, if it's a larger number, let's just say x to the 5th power, don't forget x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, then the constant, right? Always stay organized. If you don't, then this is not really going to work out very well. Then you're bound to make some sort of mistake. Now, of course, teachers are wonderful human beings, and I have full support of them. But some of them are a little mean-spirited. There's no way they're always going to give you a really nice problem that works out very well. This is an example of a problem that doesn't. Right? Now remember, in the beginning of the video, I mentioned that there are divisions where everything's nicely and division where, it wasn't so nice, right? There was still that remainder. And remainder is the key. We didn't want any decimal. We only wanted to focus on remainder. So let's look at how it applies to this. Once again, everything stays the same. You're dividing this large cubic function right here by this smaller one right here. So if that's the case, let's just rewrite it. X cubed minus 2x squared, good, minus 3x, good. So we have the x cube squared and then the regular and then plus constant. Okay, good. So we don't have to include any 0 whatever, right? It's all there. All right, so we're dividing it by x plus 2. That's not bad. All right, same goes. This one times some number would give us, or times something, not necessarily a number, I guess. This times something will give us x cubed. That's just x squared. Cool. So that's x cubed plus, and then 2 times x squared is just 2x squared, okay? And once again, don't forget, we're subtracting this. These guys go away. Maybe I should just do this so it's easier to see. All right, and then that's going to be negative 2x squared minus, and this is positive, so it's going to be minus 2x squared. That's going to give us a total of minus 4x squared, okay? Bring the next term down, minus 3x, okay? This times some number or something will give us negative 4x squared. Well, that's going to be minus 4x, okay? Cool. So that's going to give us negative 4x squared. That's what we're hoping for. Negative 4x times 2 is just going to be negative 8x, okay? Once again, subtract. Negative, negative, positive, so this cancels. That's what we want. And then this one right here is going to be negative 3x minus a minus, which is plus, all right? Plus 8x, so that's going to give us 5x. Bring the next term down. That's plus 12. Okay. X times some number give us 5x. That's simple. Plus 5, right? So if that's the case, we got 5x. That's good. 5 times 2 is 10. Okay. And then once again, we subtract. And then this goes away. Good. And now we have 12 minus 10, which is 2. Okay. Now, once again, we're not doing the whole decimal thing. That means what we have left is a remainder of 2. Okay. Technically, as a final answer, it is correct, but not all that great. So the best way to write this is actually x squared minus 4x plus 5. And instead of the remainder 2, just like the other one, right? Instead of the remainder 1, it's going to be whatever the remainder is over what you're dividing by. So that's going to be the same thing. Plus, remainder is going to be 2 over what we're dividing by is x plus 2, right? So this is our remainder right here. Let's just pick a big R right there. That's our remainder. The final answer is this whole thing. Make sure that when you write it, oh, that's another good looking too. All right, make sure you write this whole thing as your final answer, right? X squared minus 4x plus 5 plus the remainder 2 over whatever you're dividing by. In this case, x plus 2. Okay, so that would be your final answer. Now, hopefully by the end of this video, you realize that long division is actually not as terrifying as it originally seemed when we first see it. Right? If we can do division with remainder, then we're basically good. We just need to make sure, once again, we know what's multiplying whatsoever, because we're always trying to cancel out. And afterwards, remember that we're always subtracting. So when we subtract, we make sure we got to distribute the subtraction sign all the way through. to make sure that we don't do any computation error. And lastly, you encounter polynomials with missing, I guess you could say, coefficient or zero coefficient, right? Remember the example, we had the x cubed plus 8, right? There's the square that we didn't see, and then the x to the first power that we didn't see, right? Because the front number is 0. So what we do when we do long division and we realize that's the case, we have to make sure that we include that in there. Even though there's 0, we're going to put it there as a placeholder so that we don't get confused when we're doing this whole subtracting and canceling, right? Other than that, once again, long division is nothing more than division, and sometimes division with remainder. So hopefully this video made it a lot easier so that the next time you see it, you're not as terrified, it's not scary at all, and we're good to go. Thank you for watching this video. See you in the next one.